Section 5.3, the definite integral as area. When f of x is positive and a is less than b, the integral of f of x dx is the area under the graph of y is equal to f of x between x is equal to a and x is equal to b. So if the graph of f is entirely above the x-axis, there is no difference between the integral and the area under the curve. When f of x is not entirely positive and a is less than b, the integral from a to b of f of x dx is the area above the x-axis minus the area below the x-axis between x is equal to a and x is equal to b. So if the graph of f of x is not entirely above the x-axis, there is a slight difference between the integral and the area under the curve. Let's look at an example. Given the graph of f of x, evaluate the given integrals. If we consider the integral from 0 to 7 of f of x dx, we notice that we have an area of 18.8 above the x-axis, and we have an area of 20.5 below the x-axis. So we take the area above the x-axis minus the area below the x-axis, and if we calculate that, we end up with negative 1.7. So when you evaluate the integral and you end up with a negative number, that indicates that you have more area below the x-axis than you had above the x-axis. If we evaluate the integral from 3 to 9 of f of x dx, we notice that we have an area of 20.5 below the x-axis, and we have an area of 5.4 above the x-axis. If we calculate, we end up with negative 15.1. So this time we had significantly more area below the x-axis than above the x-axis. For part C, we want to know the integral from 0 to 9 of the absolute value of f of x dx. The fact that we are evaluating the absolute value of f of x would take all of these areas and make them positive. So while this is the graph of f of x, if we wanted to draw a graph of the absolute value of f of x, we would have this point at 5, negative 8 would be moved to 5, positive 8, and a rough sketch might look something like this. So this graph represents the absolute value of f of x. And now we would be considering this area, and this area. But notice on the graph of the absolute value of f of x, all of these areas are above the x-axis. So when we add them up, we would have 18.8 plus the 20.5 plus the 5.4. And we would get 44.7. For part D, instead of considering the graph, the absolute value of f of x, now we're still considering the integral from 0 to 9 of f of x dx. So if we consider the integral from 0 to 9 of f of x dx, we would have 18.8 minus the 20.5 plus the 5.4. And we would evaluate the absolute value of that. So 18.8 minus 20.5 plus 5.4. So we have the absolute value of 3.7. which gives me 3.7. So notice the difference in the position of the absolute value. If the absolute value is on the inside of the integral, as it is in part C, we consider the absolute value of the graph. All the areas become positive. If the absolute value is on the outside of our integral, we first evaluate the integral and then we evaluate the absolute value.